study that we've run for the last year on Santa Paula Creek. So just a quick outline here of the presentation. I'll start out with an overview of the watershed. I know you're all probably pretty familiar with it, but I want to make sure that we're all on the same page. We'll quickly list off stakeholders, which is basically you all, but also the public. And then we'll get right into the study, how we designed it, a brief overview of the results. I'm not going to bore you all with 15 different graphs. I'll share about a half a dozen of them, and then a summary of the results and our conclusions. We've also created an online storyboard, and we'll get to that at the end, but this is a tool that we hope can help to provide some outreach to the public on what we've done here and what it means to have a clean watershed. And at any time, if anybody has a question, you can drop it in the chat, or actually it's hard, sometimes it's hard to see in the chat in presentation mode. So just speak up and interrupt me. There's not a lot of us here, so that's totally fine. So this study was done on Santa Paula Creek. It's a perennial creek tributary to Santa Clara River, runs north into the Sespe Wilderness out of the city of Santa Paula, which is where it meets with the Santa Clara River. That upper watershed is largely undeveloped. It's in the Sespe Wilderness. There's even not really a lot of hiking access, especially since the Thomas Fire. The one trail that goes back into the wilderness is pretty well overgrown, as I know from experience now from conducting this study. But that lower watershed has many potential impactors to water quality. It's a transportation corridor with Highway 150 running through there. The Thomas Aquinas College is right there. That little purple star in the middle is right at the confluence of Cesar Creek and Santa Paula Creek running up the canyon here. There's oil and gas interests kind of in the middle area of the watershed. There's agriculture throughout, although obviously not in the national forest regions. And then there's also extensive recreational areas. There's Steckel Park, it's a county park. There's a KOA campground, which is actually on Steckel Park on county property, but administratively is considered separate for the purposes of this study. And then there's the Santa Paula Canyon Trail. Starts at the confluence of Cesar and Santa Paula Creek, and then runs up along the canyon of Santa Paula Creek. Most people only hike up to the Punch Bowls, about 4 miles up, which is a very scenic swimming hole area, but the trails actually do continue along the canyon farther north. So we've got quite a few potential impactors here, and that brings us to the motivations for the study. So there's a history of fecal indicator bacteria detections in Santa Paula Creek. This is both at the Harvey diversion and also throughout the creek. Now, fecal indicator bacteria are generally considered to be 3 different kinds of bacteria: E. coli, total coliform, and fecal coliform bacteria. And I want to emphasize the word indicator here. So these are indicators, or considered to potentially be indicators of human, specifically fecal matter pollution. They are not directly linked, but the idea is that we have to study somehow some indicators that tells us if the release is occurring, if there's an impact to human health. So currently, there are thresholds for fecal indicator bacteria to determine if there's a public health risk. These are different for freshwater versus saltwater. For saltwater, for example, the beaches throughout Southern California are monitored for fecal indicator bacteria. And if certain thresholds are met for E. coli or total coliform, or the ratio of fecal coliform to total coliform, then that's when they go out, when the regulators go out and post those signs at the beach that say public health risk, please do not enter the ocean. This especially happens after storms. It's pretty well documented that stormwater mobilizes a lot of contamination from watersheds, and that gets flushed out into the ocean, leading to conditions that might not be great for public health. Unfortunately, that's when the surfers all want to go out, when the waves are bigger. So that's actually something that's becoming very well studied throughout Southern California, or these potential health impacts of or linked to FIV in the surf zone. In creeks, in freshwater, the restrictions or the thresholds are not nearly as well defined. Only E. coli has a risk-based threshold for freshwater recreation areas, but Santa Paula Creek is a Recreation 1 listed creek. That is designated as one of the benefits of this creek is body contact recreation. And we see that at great little swimming holes like this one up in the punch holes, and farther down in the canyon along Steckle Park and the KOA, where users have also created small dams for pools for them and their kids to play in, and they hang out there all day. So that's one of our major motivators, is that there's lots of history of FIB detections that leads several of the stakeholders here to ask some questions. Now, one of those stakeholders is the owners of the Harvey Fish Diversion. They are aware of the E. coli detections at and above their diversion, and CalTrout is working with them to improve the fish passage there. So we embarked on this study in July of 2021 and worked on the creek for just over a year. And our goal here is to engage with all the stakeholders. We're scientists. Our goal is just to provide objective data, provide some recommendations, and hopefully we can all work together to find a way to make this watershed cleaner. Just a quick list here. I don't need to read off all of these, but I do want to emphasize the public stakeholders. This is a really extensively used recreation resource. Our understanding, both as Rincon as a company, but also my personal understanding as a very frequent trail user through mountain biking and trail running, is that Santa Paula Creek is really one of the few outdoor natural recreation outlets for the region. So it's really an important resource for the trail users, for the park users, and even for the students at the college there. During the time I spent on the creek and on the trails for this study, I frequently saw a very wide variety of people out there, which always makes me happy. And the last thing that I want to come from this is the conclusion being that we need to shut down access. So that's a little bit jumping the gun there, but I just wanted to plant that seed early that I personally hope that one of the outcomes of this is a holistic approach to watershed management within Santa Paula Creek. So this is the overview of the study. What we were doing was looking at potential FIB sources, specifically upstream of the Harvey diversion structure. In order to do that, we divided the stream into 7 reaches. On our first 2 visits, we actually walked the entire creek. This was actually really important because it allowed us to observe conditions with our eyes and with our cameras on the ground, things that we wouldn't necessarily see in the remainder of our visits, which is going to these points downstream of each reach, which were our designated water quality sampling points. So we collected samples from 7 locations, 1 at the diversion, 1 just downstream of the KOA. Here's the KOA on the east bank, 1 just downstream of Steckle Park. Most of the recreation Steckle Park is here on the west bank of Santa Paula Creek. And then we had this reach in the middle. We internally designated this the tar reach because of how many tar seeps there were on our first couple of visits. We waded through that and got very tarry. And that was actually an interesting and important exercise for us to undertake because it really highlighted the contrast between these different reaches. Downstream, this is at the Mupu Bridge, just on the north side of Steckle Park. Downstream of it, it's very obvious that there's lots of recreational activity. There's lots of access. With access comes activity. There's the park there, there's the KOA here. It's relatively close to the highway, so it's also possible to park and pull outs here and very quickly access the creek itself. So in these reaches, we were able to see impacts of that. We were able to see trash along the creek, diapers, toilet paper, human fecal matter even. Whereas upstream here, the access is very limited. There's private property on the east bank. There's a very steep, longer embankment down from Highway 150. There's also the tar seeps that just make it a generally unpleasant place to hang out for the day. And these are not pools that you want to hang out in because you're going to come up smelling covered in tar. We also made it upstream of the confluence here. We did take a sample regularly from Cesar Creek just upstream of the confluence, but we didn't investigate specifically sources along Cesar Creek. So that is an entirely other study that could be done. But what we did was just collect samples right above the confluence to determine what its inputs were to Santa Paula Creek. We also took a sample from Santa Paula Creek just upstream of the confluence on the Santa Paula Creek side to integrate those water quality inputs from the Santa Paula Canyon area. And then not shown on this map is our farthest upstream location, which is at Jackson Hole Backpacking Camp. This is about 4.5 miles upstream in a relatively straight line. Via trail, it's about 5.5 miles. I had the pleasure of collecting samples from this 3 times as a trail run. Had a lot of fun doing that. It's not often that I can bill some of my time for running. But it ended up being actually a very important location because what this provides is some data on what the water quality looks like coming in from that untouched upper watershed. So I ran up there with a backpack with a camelback full of ice, so kept all the samples within the temperatures required and the holding time required, and then made my way back down, in time to get the samples off to the lab. And so there were 3 main sample types that we collected at these locations. We collected, obviously, the FIB samples. These were just taken down to FGL, Gregor's lab in Santa Paula. Very convenient that there's a lab just a 5-minute drive away from here. And so those were regularly collected approximately every 2 weeks. I think in the end, we got 26 samples, including the targeted samples from these 6 locations. We only did three visits to the upper one because it was quite a larger effort to get samples from up there. We also collected septic system metals tracers. So these are barium and bromide and chloride. The research indicates that in septic effluent, there's higher concentrations of some, but not all metals. And so this allows us to differentiate between natural dissolution of salts from the geology versus inputs that might be coming from a point source from a leaking or poorly engineered septic system, or even the on-site wastewater treatment system, which is located here at Thomas Aquinas College. Now, they do have an on-site system, but it discharges to a spray field up here. It's a modern engineered system. So we assume that it's regularly maintained and inspected, but we did take samples, for example, from here and from downstream that could potentially tell us if there's some problem with that. And then there was a third tracer that we analyzed for. It certainly was not cheap, but it's a cutting edge tracer called human factor 183. And this is a human DNA marker. This is a specific bacterial DNA, and the bacteria only lives in the human gut. So it's mostly prevalent only in human fecal matter. There is some crossover with other mammals, especially with dogs, because they live with us and they eat our food and they're in very close proximity to us. And potentially a little bit of crossover in deer, especially in areas where there's trash that's left around, which, spoiler alert, is here. There's definitely trash around. But it's a powerful marker in that in high concentrations, it tells us that there is an active point source of human fecal matter in a water body. The bacteria from which this is derived live in the human gut, and they don't last very long outside. They get outcompeted. So once it ends up in the creek, they get outcompeted by the local bacteria. And within 10 days, they see a several order of magnitude decrease in activity. So if we were to see a large amount of this DNA in the water, that would tell us that there is a close by active source of human fecal matter. And that really cuts to the motivation of this, which is that there is a local sentiment in the area that I've heard for years of working in this area as a geologist, that it's got to be the KOA. I really don't understand the basis for this, but I heard this from multiple community members, construction workers, and the like. For some reason, everybody seems to think that the KOA has some kind of poorly engineered septic system. I don't know where that came from, but that's the word on the street. And that's one of the hypotheses that we're testing. That is the KOA just one major point source here? Is it Steckel? They're also on septic. Are they a major point source? Or is it something else somewhere in the watershed? So we spent a year on this creek, visiting roughly twice a month, did a few targeted stormwater sampling events, although that was fairly difficult because there wasn't a lot of stormwater. But we did actually happen to be out there on December 30th last year when close to 400 CFS was flowing down through the canyon. So we actually got an incidental stormwater sample that day. So we spent quite a bit of time both collecting samples, but also just observing conditions between our initial visits, our regular visits to these 3 locations, and then my trail runs up the canyon. We had a lot of opportunities to make more qualitative observations on the amounts of trash and the kinds of trash that we were seeing, things like diapers and toilet paper and even human fecal matter in the floodplain of the creek. So with that, we'll get to the results. Again, I'm not going to show everything here. We have a nice long report that I imagine will get emailed your way that you can take your time to digest. But I just wanted to point out a couple of the findings of our study. So the first one is that fecal indicator bacteria varies seasonally. What we have here is the duration of our study from June of 2021 until June of this year. And there are two lines on this graph. The first one is the reported visitors at Steckle Park. The last year for which reliable data is available for this is 2017, because a lot of changes happened after the Thomas fire. But it's not really surprising. What we see is that there's a lot of visitation in the summer. As it gets cooler, people stop going. The water is not as enticing to go hang out in the creek all day in November and December. So visitation decreases, and then it increases again as we move into the warmer months of the spring. We see the same thing in self-reported numbers from the KOA. They report both numbers, and they also report their septic system estimated outflows during that time, and it basically directly mirrors the number of visitors. In fact, at the KOA, they don't even do a direct measurement. They just assume that each visitor produces 100 gallons per day or something like that. So it's just a direct linear correlation between the number of visitors and the septic effluent. And what we see on the FIB is essentially the same pattern. We see higher levels. In this case, this is median levels of E. coli. We see higher levels in the late spring and summer. It decreases during the winter. There's fewer people. The temperatures are cooler. And then as people return, the levels go back up. So at the outset, this could be interpreted as, oh, maybe the septic system has an influence. But there's multiple factors here. There's the septic system, but there's also just the presence of people and all the impacts associated with that. I just want to point out that we show the median here because with biological data, oftentimes with bacteria, the concentrations span orders of magnitude. So the concentrations are not normally distributed. So it's really not appropriate to use a mean and a standard deviation. If I do that, the standard deviation error bars basically take up the entire graph. Whereas in this case, these are medians and quartiles of multiple collections of data for each of these points. But it's pretty clear that there's a seasonality to the data. There's also some variety by location. We'll ignore this one right now. This is the upstream end. This is up in the wilderness, and then this is the river flowing downstream at our different sampling locations. And what we see is that natural areas may have a biofiltration effect. So here we have the confluence. This is Cesar, and this is Santa Paula Canyon at the trailhead. We have a relatively high amount of E. coli. This specific data, I picked this because it's the most obvious in this rain event data, because there's a little bit more flushing of the watershed occurring. And we see relatively high amounts in places where people are, where there's a lot of foot traffic on the creeks. But then we get to the tar reach, which is much more natural. And by the time we get to Steckle, this is again during rain events, the flow of the river through the tar reach seems to have resulted in a little bit of a decrease in concentrations. This actually isn't a major decrease. Statistically speaking, we had enough data here to run non-parametric comparisons of the distributions, and it's actually not significantly different, although that if we had a bigger data set, it might become, but visually at least, it does seem like the tar reach is resulting in a little bit of cleaning. Now, obviously here at the wilderness, we see this dramatic difference between the water quality in the wilderness area, which basically doesn't have any E. coli in it, and then the E. coli concentrations downstream. Now, getting to the sources, what we're really curious about here is there a point, one or more major point sources? It would actually be very convenient if we had identified one, because that is easier to solve than a general watershed problem. If we were able to say, hey, it looks like there's this giant spike in the data as soon as we get to Steckle or KOA, then we can turn to county parks and say, hey, you've got a problem that you have to address. But both in the FIB data and also in the metals tracer data, we don't have any indication that there's a major point source contributor to FIB in the creek. This, for example, this is the chloride-bromide ratio. Chloride and bromide are both naturally present in the geology in the area, especially in the sedimentary rocks that we see throughout here. And The amount changes, but generally in sedimentary rocks, the chloride and bromide, the ratio of the two remains the same. When chloride goes up, bromide also goes up. When it goes down, the other goes down. But that's not true in wastewater effluent. In wastewater effluent, the amount of chloride is much higher than bromide. So what we would expect if there was a major source, especially a major downstream source, is that there would be some spike in this ratio. There would be more chloride present. And we do see a little bit more up here, higher ratio at the Santa Paula Canyon trailhead. But it's not a huge spike. These ratios here are all within the range of natural conditions shown in the literature. And crucially, there's no big change from the tar reach to Steckel to KOA. And in fact, it seems to be trending a little bit down. So this is just one piece of evidence that is helping us reject this hypothesis that there's some major point source contributor to FIB in Santa Paula Creek. And then finally, we get to the HF 183 results. I can't even make a nice graph of this because all of the results, virtually all of the results are non-detects. We have a couple of isolated minor detections. Just to give some context on these numbers, these are all around 10 to 100. Our highest number is 126 out of 4 detections. But most of them are non-detects or below the limit of quantitation. To provide some context for these numbers, human direct samples from wastewater treatment plants are on the order of 1 million. And we're seeing 10 to 100. And those are the highest numbers we're seeing. So again, we're only seeing minor detections. We're not seeing any big standout detections that are telling us that there's some significant and also ongoing release of human fecal matter to the creek. If this was a leaking septic system that was making it to the creek within 10 days, we would see some giant multiple order of magnitude spike in detectable concentrations of this DNA. But we're not seeing that. We really just see background concentrations. Now, interestingly, here at Jackson Hole, which is up at the backpacking camp, we even had one minor detection there. We spoke with the lab about this for a bit, and they've been doing a lot of research in this area in San Diego for the beaches, and they're saying, yeah, anything in the range of under 200 is basically just background levels. It could be anything. It could be deer. Nothing to conclude from that. It is interesting because that is way up in the watershed. Maybe somebody had visited it the day before I got there, and there was a little bit of human fecal matter that made it into the creek. Who knows? But it shows how sensitive this method is, and the outcome here is that we're not seeing anything pointing to a ongoing release of human fecal matter. So then finally, we get to the crux of it here, which is that water quality in the upper watershed is significantly different from the lower watershed. We could dissect the variation between these points as best as we can. We can blur our eyes, and I can be a good geologist and wave my hands around. But really, as much as we see this little dip here, it's not really statistically significant compared to the major difference in water quality coming from the upper watershed. So even though we don't have a single point source in the lower watershed, there's a pretty clear difference in water quality between the place where there are frequent human impacts, frequent uses, agriculture, trails, the road, versus the upper watershed. And on our visits, we observed a lot of this. We observed a lot of trash, a lot of human fecal matter. I don't want to say a lot, but we observed human fecal matter. We frequently observed toilet paper within the floodplain in the creek, as opposed to in this natural area where basically nobody goes. According to the Hike Los Padres website, there's like a single-digit number of visitors that make it all the way up to this Jackson Hole campground every year, and that was pretty clear from my visual observations. It goes from being a pretty trashed watershed up through the punch bowls to a fairly pristine as far as the amount of refuse that's along the creek upstream of that. So, here's just a nice nasty example. This is in Steckel Park. just upstream of the Mupu Bridge. And here we have several actual baby diapers just discarded along the creek. And this is something that we saw quite frequently. It almost became a joke that we would be walking along the creek and we would just do a diaper count. Oh, there's another one, there's another one. And, it points to the human behavioral aspect of this watershed health. So to wrap it up, we really don't have any indication of point sources of human fecal matter. We have plenty of more qualitative observations of potential sources distributed throughout. We've got all the toilet paper, diapers down along Steckle Park, trash under the bridge, at the trailhead. And what it points to is that there is no single point source, but there is a distributed watershed health issue here. Water quality in the developed part is significantly different from water quality in the undeveloped part of the watershed, which should come as no surprise here. Our ultimate conclusion and recommendations is that we need to control what we can control. Human behavioral issues became pretty clear in this study. The amount of trash, the amount of fecal matter, and then the lack of opportunities for people to have the correct behavior. There's limited trash cans, especially along Santa Paula Canyon Trail. There are no toilets at the trailhead. Something that could be done is adding toilets to the trailhead, but also a mile up. I mean, we've all gone on hikes, and we know that when you go out in the morning on your hike, you may not realize it when you're at the trailhead. It may not be until a mile in that you realize, oh shoot, I've made a mistake. So that that's one potential recommendation on that oil pad there. Maybe there could be a toilet installed a mile in on the canyon. But some public outreach and education is required. This is a tough place, even for a experienced outdoor person, to use the correct methods for waste disposal. To get 200 feet away from the creek in Santa Paula Canyon and dig a hole 6+ inches deep is pretty difficult in a gravelly, rocky canyon with a lot of bedrock exposures, not a very wide, flat floodplain. It's difficult to get to a good spot 200 feet away from running water here. So there has to be a public outreach effort. And this perhaps is not highlighted in a better place than at Steckle Park, where there are bathrooms up on the bank. There are bathrooms right there. There's 5 different bathrooms within Steckle Park. There's trash cans everywhere, and yet the dirtiest area of the creek as far as human impacts was along Steckle Park. People are going and recreating there. They're building dams. They're hanging out. They're drinking their Coors Light. There are a lot of Coors Light cans along there all day long. And I think we've all been in that boat. You're hanging out down by the river, and you think, do I really want to turn around and walk back up to those toilets? So there's the behavioral issue here. It's hard to quantify it exactly, but at least we're able to rule out, I think, through this study that there is some single major source. Now, like I said, conveniently, it would have been convenient if there was a major source that we could address. But instead, this points to a more holistic solution to change people's behavior and do everything we can to get this watershed clean without more strict enforcement.